to part C, which is f plus g. This is not going to be hard. Everything is just nice and simple. So let's go through it. So we have f of x being equal to x squared plus x minus 6 all over x plus 5. And we have g of x being equal to 1 over x squared minus 4. Now we can say f plus g is just going to be equal to x squared plus x minus 6 all over x plus 5 plus 1 all over x squared minus 4. Now, we're going to keep it like this. I think it's easier for us to solve it like this. It's very easy. We're going to say for continuity at x equal to 2, I can say f plus g of 2 is going to be equal to the limit as x approaches 2 of f plus g. Right? And this is going to be equal to, we can say f plus g of 2 into it is just going to be, let's first put f plus g of x. This is going to be equal to x squared plus x minus 6 all over x plus 5 plus 1 over x squared minus 4. Then we can say f plus g, 2 of that, okay, of 2. So f plus g of 2, this is going to be, as we say, f of 2, wherever there is x, we're putting 2 squared plus 2 minus 6 all over 2 plus 5 plus 1 all over 2 squared minus 4, which just becomes here 4 plus 2 minus 6 which is over 2 plus 5 plus 1 over 0. So this just becomes 0 over 7 plus 1 over 0, which is going to be here 1 over 0 is undefined. So this is undefined. So therefore we can say that, therefore we can say f plus g, which is equal to x squared plus x minus 6 all over x plus 5 plus 1 over x squared minus 4 is not continuous, is not continuous at x equal to 2, and would be done. This is a solution for this part. We go to part D.